In this video, I break down the solutions for the challenge 1 of Ethernaut CTF, which is the fallback challenge. This video is part of a series that I am doing for the solutions of every challenge in the Ethernaut CTF. So stay tuned for more solutions coming. I try to explain every step of the way to resolve the challenge so that you can do it on your own easily after watching this. So hello and welcome to this DecentraWise channel. I am Pedro, and here we share information about Web3, blockchain development and security. So if you were interested in this kind of things, please, you know what to do. So keep tuned for these videos solving all the challenges soon. I will be posting them really soon. So let's jump right in. Right. So to solve our challenge, we need to go to ethernaut.openzeppelin.com and there select the challenge number 1. Okay, and as well open the console so that we can play and interact with the challenge, right? So when you open the challenge, you will see something like this: the name of the challenge, fallback, and the level address, right? If you have not this, you probably need to install MetaMask or something like that. Please add to our first video of this series, which is the level 0 video, where I explain how to install properly MetaMask and how to get funded to your account so that you can play with this city. So with this level, what do we need to do? The regular thing: check what code they share with us and get our new instance and play with it, right? So let's do it. What do we have here? We have to claim the things that we have to do in this challenge is to claim ownership of the contract and reduce its balance to 0. Sounds fun, right? So what in order to make it happen, we have, of course, I already told you, the ABI of the contract that we can inspect in the contract variable, and we can interact with the contract, and we can use the methods that we have on our help command, and probably it will be interesting to understand what fallback methods are. Okay, so let's dive in. So we have a contract that is called fallback, and this contract has a mapping of contributions and an owner, and the owner is set in the constructor for the message sender, right? So the deployer of this contract will be the owner, right? And initially the contributions for message sender are set to 1,000 ether, right? So this person has 1,000 in contract, the owner. So let's test that. Let's get our instance. There you go. Let's wait. And we have it. So check the address. We have the address. And let's inspect who is the owner. Await contract.owner. So the owner is 3C blah blah blah, which you can see that is the level address. So it's the deployer of this contract. We have a contribute function, and this contribute function is payable. So we can send ether to it, and it will increase our contributions in the value, and we cannot contribute more than 0.001 ether, right? And if our contributions are bigger than the contributions of the owner, we become the owner. That's okay. So and the fallback function has also those properties. So if we send a value higher than 0 and our contributions are bigger than 0, then we become the owner. So this is strange, right? this is okay, but this is probably a bug. So let's exploit it. So what do we have to do? We have to contribute something, and then it will pass this test. And then we have to send something to the contract. One way is enough, and we will become the owner. So it seems, right? And then we can withdraw whatever there is. So let's do it. So in order to perform a contribution, we need to send less than 001 Ether, right? And we will have so what we have to do is to contribute a value. So let's do it. Await, usual, contract, contributes, and let's send a value 1, okay? So we are sending one way to our contribute call. See, transaction, boom, wait for it to be validated, and there we go. We have a transaction receipt, so it has passed. So right now we should have a contribution, and we are able to pass this test. Now we need to pass this test. Message value greater than 0. So what happens here is that we need to send to the contract one way. So let's try it. We do await contract dots, and we send 1. That's it. And let's do a transaction, and boom, we sent a transaction, and see it, the transaction has been successful. So with this transaction, we probably became the owner of the. So let's check it out. Await contract dot owner, and there we go. It's our address. So we changed the owner of the contract, and we became the owner of the contract with just 2 way. We sent one contribution with one way, and 1 way again to the contract, the owner. So right now we can withdraw because it's the function that it's only owner, and we can withdraw what's on the contract. So let's do it. Await contract dot withdraw. There you go. And transaction. Wait for it to be validated, and we are done. So by this time we should have stolen the funds from the contract, and we should be the owner of the. So let's submit the instance. Wait for it to be mined, and there we go. We solved this. Okay, so this was an easy one. We just needed to read the contract and understand where the flaw was. So the flaw was in this fallback function. We were requiring just these 2 checks to have some value, to send some value to the contract, and to have the contributions bigger than 0. So any contributor to this contract could easily become the owner without surpassing their contributions, right? By exploiting this flaw in the contract. So this is it, guys. This is as easy as it gets. We just sent a few transactions, and we are the owner of the contract, right? So hope you got value from this. Hope you will be able to solve it on your own and in your challenge. So stay tuned for more videos like this, explaining how to finish the Ethernaut challenge CTF, and send us comments in the comments below. Ask us questions, anything. We are here to help you guys. And if you got value from this video and don't mind me touching the microphone all the time, just press the like button and subscribe for more videos like this in blockchain development, Web3 development, and security, as always. So thanks for watching, and see you in the next video. Cheers. Bye-bye.